common thought in our contemporary society is that the existence of God is a matter of faith, and that matters of faith can't be reasoned about. So two claims are very commonly accepted, right? So, in particular, if the existence of God is a matter of faith, and matters of faith can't be reasoned about, then the existence of God can't be reasoned about. Not everyone accepts this. There are plenty of atheists who think the existence of God can be reasoned about and shown to be false. But there are also some people who believe in God and who think it can be reasoned about. I think actually both statements are false. And in fact, I think this has standardly been a part of Christianity. The New Testament denies both statements, that the existence of God is a matter of faith and that matters of faith can't be reasoned about. So Paul says in Romans that ever since the creation of the world, God's nature has been clearly perceived in things that have been made. Clear perception doesn't seem like the sort of thing that is a matter of faith. But on the other hand, even for faith, Peter says that we should be ready to make a defense to anyone who wants an accounting, which suggests that matters of faith can be reasoned about according to the New Testament. And of course, as I said earlier, many atheists will agree that it can be reasoned about. They will just disagree as to the direction that the reasoning will take. In fact, I think if God exists and made the world, it would be strange if the existence of God was something we couldn't reason about and couldn't in some way see. I mean, if God made absolutely everything, it would be some kind of strange, very strange, if he left no signs of himself having made everything. I imagine somebody makes lots and lots of things and leaves zero signs. That would be very strange. I mean, maybe God could pull that off, being all powerful, if he tried really hard. But he would have to try, it seems. So if God made everything, I think we would actually expect to see signs of him in creation. And conversely, if there weren't any signs, I think there would be some evidence that there is no God. This would be a case where, absence of evidence is not evidence of absence, but maybe in the case of God, we would expect there to be evidence of God's existence if God exists. And so if we don't find this evidence, that would be some reason to doubt that God exists. Maybe not conclusive reason, but some reason. So I'm going to offer a very classic kind of argument for the existence of God called the Cosmological Argument. The main lines of thought here go back to the Middle Ages, to Thomas Aquinas in the West and Islamic philosophers in somewhat further east. But there are some new ingredients, as often in these things. The main argument's like this. We start with an innocuous statement. Something causes something. My opening my mouth and causes you to hear things. Okay, that's it. That's all we need for this one. Second premise. This is one I won't spend too much time on, but there is no circularity of causes. You don't have this thing causing this, and then coming back and causing the one we started out with. I'll say a little bit more about that, but not much. This one I will say a lot about. There is no infinite backwards chain of causes. What do I mean by that? Well, I said in the first premise that there is such a thing as causation. Something can sometimes something causes something. Well, once you have an effect in a cause, you can ask, does the cause have a cause, or is it itself uncaused? So, my cause is maybe my parents. Do they have causes? Yes, of course. My grandparents. Do they have causes? Yes. My great-grandparents. And so on. Well, and so on forever, or so on up to some point? Well, this premise says it's not forever. There are no infinite backwards chains of causes. At some point, any backwards chain of causes stops. This is a premise that was argued for very creatively by medieval Islamic philosophers from the Kalam school. They came up with interesting arguments based on interesting paradoxes that you get either from the very idea of infinity or from the very idea of an infinite chain. And I'm going to offer some newer arguments based on some newer paradoxes that people have come up with in the past half century or so for the same thing. So this is in the spirit of the Islamic Kalam school of the medievals, but it's not the same arguments that were using. But I will also do this. I will offer a second parallel argument. So while I do actually think there are no infinite backwards chains of causes, I'm going to argue that even if there is one, there still would have to be a first cause beyond it, something that causes the whole chain. And this is something that St. Thomas Aquinas was defending also in the Middle Ages. He didn't actually like the medieval Kalam arguments of the Islamic schools. He thought that there could be an infinite past, and it could be an infinite chain of causes, but there would still have to be a God to produce that infinite chain of causes. So we'll think about that. So there's sort of two ways at this point. The argument kind of branches into either this way or this way. Either way, you get to conclude, so there is a first cause. Why? Well, something causes something. The cause of that something itself either has a cause or doesn't. If it doesn't have a cause, there's a first cause. What do I mean by first cause? I just mean something that has no cause. Something that is itself a cause but doesn't have a cause. Well, if that thing that caused the something has a cause, we can go trace further and further back. We can't have a circularity of causes by 2. If we take 3, then we can't go forever, so somewhere we have to come to a stopping point. We have to come to something that doesn't itself have a cause. And by number 4, even if we can't rule out infinite chains, there would still have to be a first cause. So either way, there's going to be a first cause. And then the last part, I'm not going to say enough about. I wish more could be said. This is something that Thomas Aquinas has a lot of very interesting things on, that the first cause is God. And I'll say a little bit about, to at least make that at least somewhat plausible. It's actually in some way, in the form of the argument that I will give it the weakest part, but that's kind of good, because what I want, one of the things I'd like people to take away from this is a very plausible statement. And those who believe in God and those who don't believe in God could actually in principle agree on this and not all immediately go to this. And then once you agree there is a first cause, then this is actually an interesting thing where atheist and theist thinkers could come together and think, so what is this first cause like? Can we agree on at least some of the properties of that first cause? Can we say anything about it shortly? I think that's an interesting project. My own view is that there's good reason to think the first cause is God. But some of you might want to stop at 5. Some of you may want to not even get to 5. We'll see. Okay. So let's go to so what I'm going to do is go through each of the premises, each of the steps of the argument one by one. So they're here briefly summarized on the left side. So the first one is something causes something. Well, yeah, obviously your parents have caused you to exist. You know that. More generally, modern scientific explanations often, perhaps not always, but often involve causes. For example, evolutionary processes cause the existence of a diversity of species. Moreover, it's not just in the theories themselves, but in the lab that causation is involved, right? Science is based largely on experiments. Experiments are cases where we carefully cause effects. Okay, right? So this is kind of super uncontroversial that something causes something, but I just want to beat this to death. Because there are actually some philosophers who deny this, who say there is no such thing as causation at all. But there are philosophers who say just about anything. As you will see from me, perhaps. Okay, the second thing, slightly, right, this is kind of, going from less controversial to slightly more, to much more controversial. This is slightly more controversial. there are no circularity of causes. Nothing can cause itself. That seems right. I mean, to cause yourself, to cause something is to in some way be before it. Well, how could you be before yourself? Maybe not in time, but in some way before it. You can't be before yourself. So nothing can cause itself. That idea is just, I think, nonsense. Or at least absurd. But for the same reason, you can't have a circle of causes, because that would be almost like causing yourself. It would be just like, because you'd be starting a chain of causes that leads back to you. A cause has to be in some way before the effect. So if you have A causing B and B causing C and C causing A, then A would end up being before B, and yet B would be before A. It would go around. And that doesn't, I think, make sense. Now, if there is no circularity of causes, so I think if you want to push me on this, we can talk a little bit more about circles of causation. You can get some paradoxes if you think there you can have circles of causation. You've got the standard ones about if you could have a circle of causation, could you have these weird self-undermining circles where you go back in time and kill your grandfather before he meets your grandma? And if you did that, who would have killed him? It wouldn't have been you, presumably. Seems better to just say you can't have a circle of causes. So if you can't have a circle of causes, so if there's no circle of causes, here's what's got to happen. As you go back from effect to cause, say you move from you to your parents, your grandparents, your great-grandparents, either one of two things will happen. You'll reach some cause where you can no longer say this has a cause. You'll have to stop somewhat having causes. Or you will have an infinite regress of causes, right? One of two options. So we're going to now, in the next two bits, which are going to be most of the talk, explore these two options. So the first thing I'm going to do is look at the Kalam kind of thought, that there are no infinite backwards chains. So here's first one thing that some people say. It supports this idea that there are no backwards chains of causes. We've got Big Bang cosmology. The universe begins about 14 billion years ago. Well, if it begins then it doesn't seem like we've got room for an infinite backward chain of causes. Well, maybe. But maybe we do. Maybe there was something before the Big Bang. I mean, it's a singularity in space-time. Maybe there's some worries about it. Does time, it makes sense to talk of time before the singularity. But you could have something that's before in terms of causation, but maybe not before in terms of time. So it's not completely clear. Could there be something? So maybe there is something before the Big Bang. Maybe then there's something before that, and so on, up to infinity. Well, as I said, medieval Muslim philosophers came up with really clever arguments that this can't happen. They weren't talking of the Big Bang, but just in general, backwards infinite chains of causes. And the basic idea that they had was that if you allow infinite causal chains, you will have no good principled reason to get out of a whole bunch of paradoxes that you're going to get with infinities. Now, this is not a history of the argument talk, so I'm not actually going to tell you any of their arguments, because I'm actually not convinced by any of the ones that I've seen. There may be some more that I haven't seen, but the ones I've seen, I'm personally not convinced by. So I'm going to give you some others that I am more convinced by, but they're in the same spirit, I think. So here's the first one. Philosopher Smullyan has a rod. It's a rigid rod, the kind that Newton's physics used to talk about, rigid objects that can't bend and can't penetrate other objects. Here's a little experiment. Can we balance it on the end? No, it falls, right? Now, what if I make it longer? Maybe that would help. Surely not. It only is going to get harder to balance it on the end, right? Well, so here's the curious thought experiment Smullyan had. This is, imagine that we're living on a flat planet. There's our little flat planet here. It's a big flat planet. It goes on to infinity in both directions. And imagine that we make our rod infinitely long, which should make it harder to balance, right? So here's our rod. For various reasons, you notice the density of it drops off as you go. This is so that the total mass is finite. This makes sure that this thing doesn't get completely squashed by the enormous mass of the rod. Don't have to worry about that. And then these arrows get shorter because the force of gravity gets lower as the density gets lower as you go out. That's sort of icing on the cake. The point is, it's an infinitely long rod. It's perfectly rigid, sitting above a perfectly flat planet. It should be really hard to balance, except it's actually really easy to balance because it can't go down at all. Because imagine if it were to slightly turn like that. Well, it's a straight rod, so it would hit the ground and then go through the ground. But it's perfectly rigid, and so is the ground, so it can't penetrate it. So there's no angle it can actually bend at, right? It can't bend at the slightest angle, because otherwise the lines will not be parallel, and non-parallel lines will meet somewhere. So it has to, the rod actually has to stay floating exactly parallel to the ground because of the ground somehow repelling it or something. This is strange. Okay? This is just to get you to think there's some strange things going on when you have infinity, and not just when you have infinity, but when you have infinity and causation together. Because you've got, like here, the torque around this point is caused by infinitely many interactions between the ground and the rod, or maybe infinitely many possible interactions. There's something very strange here. You would think the longer the rod is, the more easily it would fall, but no. Okay. Here's another one. I love infinite lottery paradoxes. They're so much fun. So normally, right, if you have a lottery, if you have more tickets, it's harder to be a winner, all sorts of. But you can understand a lottery that has 1 million tickets, 1 billion tickets, 1 trillion tickets. There's really nothing very conceptually very difficult about this. But you might wonder how could you have a lottery of an infinite number of tickets? Well, there are some space issues. Where do you keep the tickets? But there's also a very hard issue as to how you shuffle the tickets, how you shuffle infinitely many tickets. Well, here's a simple procedure. Suppose I have infinite amount of time. Remember, we're exploring this hypothesis that maybe the universe wasn't created and there's an infinite chain of causes, and so probably that infinite chain of causes would reach infinitely far back. So at least it seems like it's in the area that we're exploring that maybe the past is infinitely long. So let's imagine the past is infinitely long. And so here's what I've done. I had this deck of cards. I'm infinitely old too. I've had this deck of cards numbered 1, 2, 3. 2 days ago, I shuffled the top 2 cards of the deck. 3 days ago, I shuffled the top 3 cards, and so on. 1,000 days ago, I shuffled the top 1,000 cards, and so on. Any finite number of cards off the top has been perfectly shuffled by now, right? So the top 1,000 cards were shuffled 1,000 days ago, and since then I've shuffled some more cards at the top, but that doesn't disturb the shuffling. Shuffling doesn't get disturbed by further random shuffling. It stays random. This seems like, if I can have an infinite past and an infinite causal sequence, I should be able to add shuffling to the mix at every time or at every day of that infinite past. Why not? Well, so now I've got my deck of cards. It goes really far down, or maybe the cards get thinner and thinner so that the total depth is finite. And I offer you a game. Or not I, actually. It's Han Solo, the tricky guy. offers us, you and me, a deal. You and I are going to pull cards off the top of the deck, and the bigger number will win. The loser will pay the winner $10. So between you and me, it seems like a fair game. It seems like it's equally likely that either of us will get the bigger card number because they're all well shuffled. Remember, the top two cards were shuffled 2 days ago, so which one is there seems completely random. Which of them is bigger, has a bigger number on it. But to sweeten the deal, and maybe because you're risk averse and don't want to risk your $10, Han Solo offers you and me $5 each to play this game. So at most you'll lose $5, and you've got a 50-50 chance of winning $10, and you pay $5 to play. Seems like a really good deal if you approve of gambling. Remember, I come from a Baptist university. This might be a real issue for some people. Not one for me. Not when the stakes are moderate, at least. I have standard worries about addiction for gambling to large amounts. These are small amounts so far. They may get worse. Okay, so now here's the deal. You and I look at our cards. And here's what's going to happen. I actually can tell you ahead of time what's going to happen. You will look at your card and despair. And I will look at my card and despair. We will each be quite sure that the other person is the winner. Why is that? Well, let's imagine that the card on mine is, what number is that? 100,007. That's the number printed on my card. I look at my card and I see 100,007 is my card number, and I think, your card, well, is it bigger or smaller? Well, are there more cards that are bigger or more cards that are smaller? There are a lot more cards that have bigger numbers than that. There are infinity cards that have bigger numbers than that, and only 100,006 cards that have a smaller number than that. So it seems like I'm really confident you don't have one of the 100,006 cards that have smaller numbers than mine. I mean, this is reasonable. I mean, if there were imagine there are 1 trillion cards, numbers from 1 to 1 trillion, and I find I have the card number 100,000. I'd be quite sure, I'd be fairly confident that your card number is bigger than mine, because most of the remainder are mine. And I would say, how unlucky that I have such a small number. The funny thing here is that no matter what number I got, it's really small compared to the total range of cards. I mean, you might say 100,007, that's really small when you're talking of an infinite number of cards. But whatever number I got, it would seem really small. So this argument is going to work no matter what card number I get. Maybe I get a Googleplex. 10 to 10 to 10. Is that right? Or is it 10 to 10 to 100? Yeah, I think it's 10 to 10 to 100. Yeah, but that's still tiny compared to infinity. There's still only finitely many numbers smaller and infinity bigger. And we're going to always do the same kind of, roughly speaking, the same kind of calculation. What's the chance that I have the winning number? The only way I have a winning number is if you have, in this case, one of these 100,006 tickets that are smaller. But there are a total of infinity tickets. So it's this number divided by infinity, and that's 0. So I am completely confident that you have a bigger number. But of course you have, when you look at your card, without showing it to me, you have exactly the same confidence about me. Whatever number you got, you're completely confident that I'm the winner. Now this is really weird. At this point, we're each wishing we had the other person's card. And this is going to happen no matter what cards we picked out. We will each wish we had the other person's card. If we want to fill this in, Han Solo comes by and offers us a deal. If I pay him $19 and you pay him $19, he will broker a swap between us. Is it worth it? Well, I think about it this way. I am certain that you have the bigger card number. Nearly certain. Certain to a finite number out of infinity. So incredibly certain that yours is the bigger number. If you have the bigger number, I stand to... the swap will gain me $20. Because, right, if you win, I have to pay you 10. And if you win, I pay you 10. If I win, you pay me 10. So $20 difference. I'm quite sure you've got the bigger number. Way surer than 1 out of 20. So Han Solo offers me for $19 to let me swap, and that'll get me pretty sure to win $20, so that's $1 free for me. So I'll tell Han, yeah, go for it. And Han says the same thing to you, and you reason in the same way. So Han collects $28 from us, offers us to swap the cards, and here's what happens. If you can work out how these numbers work out, it turns out one of us will lose $4 on this whole game, and the other loses 24. Even though it seems like at every single step in the game we worked completely rationally. It seemed perfectly rational to go for this deal, and then it seemed perfectly rational to go for the swap once we did this calculation. The only one who won on this was Han Solo. And he can do this over and over and over, because the reasoning is going to work the same way no matter what cards we get. There's something very strange about this deck of cards that's infinite and has been shuffled perfectly. You can think of some other weird things about it. Suppose I'm drawing cards off the top of the deck. I draw one card. It's with some number. Now I wonder, will the next card be bigger? I'm quite sure it will be. It's perfectly rational for me to think the next one will be bigger, because there are only finitely many that are smaller, infinitely many that are bigger, so surely the next one will be a bigger number. So I pull that in, that's probably bigger. I now expect the one after that to be bigger. And I keep on having this weird expectation. Like, I draw 100 cards out of the deck, and I keep on expecting the next one to be bigger. But look, it's not going to be the case that all 100 cards I pull off the deck that has had the top 100 cards shuffled are going to be in increasing order. That's just really unlikely. And yet I continue to have this rational expectation. There's something very odd that happens to our rational expectations when you have an infinite deck that's really well shuffled. And yet, with an infinite past, it seems like you could shuffle an infinite deck. So there's something very strange about these infinite lotteries. Right? I mean, even without the money, right? Even without Han Solo getting richer in the game, it's just really odd that, like, whatever cards you pick out, you'd want to swap with the other person, and you would know ahead of time that you would want to swap. There's something. Okay, I want to talk about another paradox, but before that, let me do a little warm-up. So my little warm-up, I don't think it's a really nice vivid paradox in a way, but I don't think it's actually all that paradoxical, but I wanted to just mention it. This is called Thompson Slam. It's fairly famous. There's a philosopher, Thompson, in the 1950s came up with this. So we have a lamp which has a push button, and each time you push the button, the lamp toggles from on to off. And the lamp is, let's say, off at 10 a.m., and then you push the button at 10:30, and so now it's on. Then at 10:45, you push the button again, and it's off. And then you divide the 15 in half, and at, 10:52.5, you push it again. And you keep on dividing up the time between what's the current time and 11 o'clock, and you just keep on pushing the button at halfway points. And it toggles faster and faster as you push the button. You have to push the button faster and faster. And the question that he raises is, at 11 o'clock, is the lamp on or is it off? Well, when I told this to my son, he said, well, it depends on whether infinity is even or odd. Because right after one push, it's on, and after two pushes, it's off, and so on. Yeah, it depends on whether infinity is even or odd, but of course it's neither. The categories just don't apply to infinity. So there's something strange about this. Not completely clear how paradoxical it is. It's a little strange as a story, but strange is not the same as impossible. Right? The platypus is strange, but not impossible. You have lots of strange things in our world that are not impossible. I think the problem here is that it seems like your button presses should be able to determine the outcome, but yet you can't tell what the outcome is going to be just from the button presses. I'm not sure. There's something puzzling about this. Well, you can take this lamp story and repurpose and change it so that it becomes more paradoxical. And this is called the Grim Reaper paradox. It's a more vivid and violent version of a paradox that Bernadette came up with in the early 1960s, I think. And the idea is that we've got a Grim Reaper who has a nasty weapon. And actually, we'll have more of them. We'll have infinitely many of them, of course. And we have Fred here. Fred here doesn't look very healthy, but actually Fred is extremely healthy in the story, just not in the picture. Because the only thing that can kill Fred is decapitation by that weapon. So he is so well, there are no other dangers in the story for him other than of decapitation. But there will be infinitely many possible decapitators. So a Grim Reaper is a critter that has one of these weapons, is standing by Fred, and also carries, which is not shown in this picture, an alarm clock set for a specific time. And here's what happens. As soon as the alarm goes off, the Grim Reaper looks at Fred and checks whether he is alive. This is an easy task because the only way Fred can die is by decapitation, and it is easy to check if someone has been killed by decapitation. So the Grim Reaper looks and checks if Fred is alive still. If Fred has been decapitated already, the Grim Reaper does nothing, goes back to sleep, says, alarm rang, false alarm, somebody else did the job. I don't have to do anything. There's just no point getting another scythe arrested. So there's nothing really paradoxical about what I've said. And of course, if the Grim Reaper finds that Fred is alive, he cuts off his head. Again, still nothing paradoxical, nasty for Fred, but nothing really paradoxical. Now, you could have two Grim Reapers. Maybe one has an alarm set for 10:30 and one for 10:15. We know what's going to happen then. The 10:15 alarm goes off. The 10:15 Reaper sees Fred, cuts off his head, then goes back to sleep, having done a good day's work. The 10:30 Reaper wakes up at 10:30, looks around, sees the head is off, says, 10:15 Reaper beat me to it, goes back to sleep. Fred is dead. One of them swung aside, no problem. But what if, and this is the genius of Bernadette's story, we have infinitely many Grim Reapers, and they set their times, alarm clocks this way, 10:30, 10:15, 10:07.5, 10:03.75, and so on. Each one we count the distance here by half. And there's none at 10. There's no Grim Reaper at 10. But there are infinitely many, for any interval after 10, there are infinitely many Grim Reapers that wake up during that interval. Now, when you have one deadly thing, that's bad. When you have two deadly things facing you, that should be worse. And when you have infinitely many, that should be even worse, unless they get in each other's way. We're going to stipulate that they don't get in each other's way. Okay, so they just don't get in each other's way. They're kind of skeletal, spiritual kinds of beings, so it's not like they're going to bump into each other in a crowd of infinite, and some will have trouble getting past the crowd of infinitely many. So that's not a worry. So what's going to happen? Well, Fred has got to be dead at 11. Why is he dead at 11? Because there was a Grim Reaper who woke up at 10:30. And as soon as a Grim Reaper wakes up, Fred is sure to be dead, because he's either already dead or the Grim Reaper kills him. So when the 10:30 Grim Reaper woke up, that either was already after Fred's demise or it was Fred's demise. So Fred has got to be dead at 11. But the 1030 Grim Reaper didn't actually kill him. This is a whodunit. We now know Fred is dead, so we need to find out who done it. So, did the 1030 Reaper do it? No, the 1030 Reaper could not have killed Fred because the 1015 one woke up beforehand. And if Fred was alive at 1015, this one would have killed him. So there's no way Fred could have survived to 1030. The 1015 Reaper just made sure of that. Right, so each of the Reapers makes sure that Fred is dead. Right? To make sure is to do one of two things, to either kill or to check for death. What about the 1015 Reaper? Did it kill Fred? No, because there was a 1007.5 Reaper earlier, and that one already ensured Fred's death. In fact, they all ensured Fred's death, and none of them killed him. And yet Fred was alive at the start. So, Fred is dead. He could only have been killed by a Grim Reaper being in the pink of health. Otherwise, none of them killed him. That seems very strange. That seems paradoxical. So we've got 3 or 4 paradoxes so far. Smullyan's rod, this infinitely long rod that floats. We've got infinite deck of cards that seems really well shuffled in such a way that 2 people will be forever willing to swap cards or something after they get the top cards. We've got the lamp, which I'm not completely sure is all that paradoxical, but opinions vary. And we've got the Grim Reapers, which to me seem quite paradoxical. What can we say about all of these in common? I think there's a nice way that you can kill all of these paradoxes. And that is to adopt a theory that I call causal finitism. So finitism is a theory that says you can only have finitely many things. I don't like it as a theory because I think it plays havoc with mathematics. Seems like modern mathematics is all about, or maybe often about, infinities of things. And it's been that way for a long time. I mean, the ancient Greeks proved that there were infinitely many prime numbers. So I don't think it's plausible to have a theory on which you just cannot have any infinities whatsoever. Though if you could, that would get rid of all these paradoxes. All these paradoxes involve an infinite number of something. It would be kind of nice if you could say there just can't have infinities. All infinity paradoxes are dead. But again, I think that would end up killing mathematics along with the paradoxes, and that's too much. So what I've thought is that with these kinds of paradoxes, you don't have to go all the way to saying you can't have infinity. All you need to do to get out of these paradoxes is to say you cannot have a case where you have an infinite number of causes in some way causally connected to a single effect. So that's my thesis. Is if you these paradoxes all come from allowing infinitely many things to work together for a single effect. So, for example, in Smullyan's rod, you've got the gravitational influence on all the little bits of the rod, infinitely many bits of the rod. In the card shuffling case, the current state of the deck is the result of infinitely many shufflings. In the case of the Thompson Slam, infinitely many button presses are the cause of the final state of the lamp. In the case of the Grim Reapers, it's a little bit complicated, but I think there are infinitely many, something like causal insurings. Each of these things is causally ensuring Fred is going to be dead. So if we adopt causal finitism, we don't allow infinitely many causes to impinge on a single effect, we get rid of all of these paradoxes. This is, I think, a good way to get rid of these paradoxes. It doesn't kill mathematics, because mathematics doesn't talk of causation, of cause and effect. Mathematics just talks of abstract things where we abstract from this idea of causation. So we have infinitely many prime numbers, but it's not like there are any causal relations. It's not like 2 causes 3 or 3 causes 5 or anything like that. There's no causation going on, and so this philosophical thesis doesn't impact mathematics at all. But it does destroy these paradoxes. So I like this. So I think there's some good reason to adopt this thesis of causal finitism that says you cannot have infinitely many causes impinging on a single effect. I think that this makes it likely that this thesis is true. It's like, I think, the best explanation we have of what's wrong with all of these paradoxes. But here is a side effect of causal finitism, or at least a feature of it. Maybe some people think it's a bug in it, but if causal finitism is true, you can't have an infinite backwards chain of causes, because that would be one thing, and before it infinitely many causes. That's exactly what I was arguing here, and what the Kalam medieval philosophers were arguing for. So we have these, if we allow infinite chains of causes, it seems like we should be able to arrange those chains of causes to have these shufflings, or these grim reapers, or some of these other paradoxes. So we should not allow infinite chains of causes going backwards. I say going backwards because I have not been able to find any paradoxes with infinite chains of causes going forwards. So maybe you have children and your children will have children. You might think that might go on forever. Unlikely. It's unlikely either on standard religious hypotheses and also unlikely on standard scientific hypotheses about the future of the universe. But at least it seems philosophically possible that this could go on forever. And I don't see any paradoxes arising from that. But that's a forward chain of causes. It's not one thing having infinitely many causes, it's one thing having infinitely many effects. That doesn't seem to be a problem. It's the having infinitely many causes that's a problem. So we've got an argument against infinite backward chains. But maybe just as some people were not convinced by the Kalam once in the Middle Ages, maybe you will not be convinced by these. So that we have the other approach, which was the sort of thing Thomas Aquinas did. So he wasn't convinced back in the 13th century by the Kalam school's arguments about various paradoxes of infinity. In fact, he had this argument that we cannot prove that the universe isn't infinitely old. And he was actually very proud of it. It was like this interesting little meta-argument that there is no good argument that the universe is infinitely old. But we can take it on faith that the universe isn't infinitely old. Because the Bible says, in the beginning, which suggests there is a beginning. But he thought that whether it's infinitely old or not, the universe still needs a cause. Even infinitely old things need a first cause. So that is one of his great contributions to this thought, is that you still need a cause for things that are infinitely old. So let me illustrate why you might think this. So here is a thought. This is a big old problem. Why the Earth doesn't fall down. It's one of the great scientific or philosophical problems of human history, which has a beautiful which comes to a beautiful solution eventually. But think about this problem. Heavy stuff falls down. like earthy stuff, rocky stuff falls down. What is the earth made of? Heavy, rocky stuff. So it should fall down, right? Okay, we've got that. But it obviously isn't falling down. It's standing still, as everyone can see. So why doesn't it fall down? Well, maybe it lies on top of something else. Right? Like a turtle. And elephants. Maybe. But then, of course, there is a new problem. Why doesn't a turtle fall down? There's one ancient Greek philosopher who, I've not been able to read, I was looking for this quote and I haven't been able to track it down, but I remember reading that quote long ago from him, who solves the why the earth doesn't fall down problem like this. The earth is on tall pillars. And you wonder, well, why don't the pillars fall down? And he says, whose bottoms are shrouded in mist. He's trying to direct our attention away from the bottoms of the pillars. Don't think about those. Right? So, okay, so you have the answer, it lies on top of something else. That's that by itself won't do. So why doesn't that thing fall down? Well, maybe it itself is on top of something else. But why doesn't that fall down? Well, you don't want to just keep on adding one turtle at a time. That just gets too boring. So you just now add an infinite number of turtles for propping up the earth. Unfortunately, that doesn't really help, right? I mean, when it was puzzling why the earth didn't fall down, it was puzzling why the earth and the turtles don't fall down, it's puzzling why the whole chain of turtles and the earth doesn't fall down, right? Adding the infinite number of things just leaves the thing unexplained. Even of an infinite chain of causes, we don't have an explanation of the chain itself. And just adding more causes doesn't help. By the way, a little bit of history. As far as I know, the solution to this problem, the correct solution, was given by Aristotle when he said that he took from other views that was already established at the time that the earth is round. Right? The problem is particularly glaring if the earth is flat or semi-flat, as in this picture. The earth is round, and gravity it goes down, but down, he said, doesn't mean that, along vectors parallel to this. Down means towards the center of the earth. That's where gravity points. And so the reason the earth doesn't fall down is because this stuff gets pushed towards the center, and the stuff from the other side gets pushed towards the center, and it's all nicely balanced. That is, in fact, the correct answer for this. We might add that gravity doesn't point just towards the center of the earth, but towards the centers of other massive objects. But he had the right idea for the solution for this problem, and it did not involve an infinite number of causes. It just involved one. It just involved the earth being neatly counterbalanced at the center, at the gravitational center. Okay. So even with an infinite chain of causes, we still need an explanation. Okay. You could say that, but here's a common response you might have that is sometimes given, is to say, yes, maybe there's an infinite chain of causes for why we exist. Goes back to Big Bang, maybe goes before the Big Bang and before that and so on. And maybe there's just no explanation at all as to why this whole chain of causes exists. That would be kind of like saying the earth doesn't fall down, it's on an infinite chain of turtles, and there just is no explanation as to why this whole chain doesn't fall down. Maybe it just has no explanation. There is an old philosophical principle called the principle of sufficient reason that says that everything that doesn't have to happen has to have an explanation. Maybe some things have to happen, like 2 + 2 has to equal 4. Maybe some of those things don't need an explanation. Maybe there's no such thing as an explanation of why 1 equals 1. I don't know. I'm open to the question. And then maybe there is an explanation for why 1 equals 1, but I'm also open to saying it just has to be that way. It can't be any other way. But if things could be another way, then the principle of sufficient reason is a pretty plausible philosophical principle that says that there has to be an explanation, a reason for why the thing that didn't have to happen actually happened. I think the history of the universe is something that didn't have to happen. So it needs to have an explanation. Why didn't it have to happen? Well, maybe one reason to think it didn't have to happen is there's so much seemingly arbitrary detail in it. Matter is arranged in these particular ways, in these particular shapes. It would be really, really odd to think the Milky Way has to have exactly those spiral arms. It does. The Orion spur that we are on has to be slightly deficient compared to the other ones, and so on. The Earth has to have continents precisely like our continents. This just doesn't seem very plausible that all this detail is exactly how it has to be. So if the history of the universe didn't have to happen, it needs to have an explanation by the principle of sufficient reason. All right, fine, but what if you just deny that? And a lot of contemporary philosophers do deny the principle of sufficient reason, and they just say, yeah, some things just happen for no reason at all. They don't have to happen, but they happen. What about that? I have a number of arguments concerning this. Here I just want to give a quick intuition. It seems to me that at the heart of science is something like inference to best explanation. We have a number of theories about how something happened, and we go for the one that explains the phenomenon best. But if you allow for the possibility that things happen without an explanation, then it's hard to see why you should ever go for the best explanation, because there's always the option, this just happened for no reason at all. And that's simpler. There's something like Occam's razor. We go for simpler hypotheses. And the one that it just happened for no reason, it seems to be simpler. I have other lines of thought. It seems to me that if something happens for no reason at all, we cannot say that it was likely or unlikely. Why is that? Things that are likely or unlikely, there's some kind of law of, it seems like there's something like a law of nature that it gives their probabilities, like the laws of quantum mechanics give probabilities for various phenomena. It seems to me that if you have something that has no reason at all, then we cannot say that is likely, and we cannot say that is unlikely. We cannot say anything about its probabilities. That means that if you think that things can happen for no reason at all, you cannot assign any probability to them happening for no reason at all. And in particular, you cannot say it's unlikely to happen. That means that you cannot think, you might wonder about this. You have a headache. Should I take an aspirin or not? Here's a reasonable bit of reasoning. It is likely that if I take an aspirin, it will relieve my headache. And it is, right? And it is unlikely to cause side effects. But if we allow for things to happen for no cause at all these probabilistic calculations get thrown off, because there's always the chance that for no reason at all, after you take the aspirin, your head will be blown up. Not because of the aspirin, just for no cause at all. We cannot do any kind of planning for tomorrow if we cannot have any probabilities for tomorrow. And if things can happen for no reason at all, then vast numbers of high-energy particles could materialize for no reason at all right here at any moment. And that just throws off all our prediction. You cannot say it's 95% likely that we will have global warming, because maybe everything for no reason at all will pop out of existence, leaving us at the background microwave radiation level, which is far below what global warming models predict. So Maybe we'll have global cooling for no reason at all. So it seems any kind of probabilistic prediction of the future, I think, depends on the idea that the future is at least probabilistically handleable, or can be probabilistically described. And I think that requires the principle of sufficient reasoning. Requires that things cannot just happen for no reason at all. And in particular, if things cannot happen for no reason at all, I don't think you can have a chain of causes that goes on forever with no first cause, because like the turtles, there will be no explanation for it. If there cannot be an infinite backward chain of causes, then we get to one or more first causes. Aquinas has argued, and I think if we think about the principle of sufficient reason, which wasn't quite his way of thinking about it, though it might have been behind some of his thinking, if there is an infinite backwards chain of causes, if there were such a one, it would still itself need a cause. And so you still have to have a first cause. You might ask, well, what if the chain has a cause, and that cause has a cause, and you've got another chain, you've got a chain of chains, and so on. There's some fun set theory and math here. You can apply Zorn's lemma and still argue there's a first cause. For those of you who know how it works. So there is a first cause, either way, which is itself uncaused. Now we can ask, at this point, this is actually, I think, an interesting thing where I think it's a good place one could stop and just ask, okay, maybe we can now agree, atheists and theists alike could agree there is a first cause. And the big investigation is, what is the first cause? Is it the Big Bang? Is it the laws of nature? Is it God? Is it the universe itself? I think these are good questions to ask. And I think there's interesting philosophical things you could say in favor of each of these options. I would argue for the God option here in the time remaining. I think the first cause is something that has to exist. It's not just something that chances to exist, because otherwise it would make sense to ask why it exists. This has always been one of the big chestnuts for theists. So who created God? Well, there has been an answer to this. And it's an old answer. And the answer is, God is a necessary being. God is the kind of being that has to exist. There are some things that just have to be so. One has to be equal to one. Thomas Aquinas gives the example of the truth. He says, the truth is something that has to exist, because even if it doesn't, then it's true that it doesn't exist. And so there is truth. You might worry a little bit about whether it's equivocating on a truth and the truth, but there's something to thought. There's some things that just have to exist. The first cause, I think, is going to be one of those things, because otherwise you could ask why it exists. And then you would have to have an answer by the principle of sufficient reason. I don't think any of the items that science talks about are things that have to exist. Science, I think, is in the business of talking about contingent things that don't have to exist. For one, science is talking of material things. Material things are in space. It seems that any bit of space could be empty. It seems like it would be very strange to have a material thing that would have to exist. I mean, imagine this chair had to exist. Like, would it have to be right here? Could it be somewhere else? Would it have to be exactly like this? I guess so. That's very strange. It's just material objects don't seem the right candidates for things that have to exist. It seems perfectly imaginable for any material object that the universe be empty of it. It's more than imaginable, we can give a causal story as to how the universe just came to be different and didn't have a material object. It just doesn't seem like material objects are the sort of thing that has to exist. Again, this is a point where one might resist the argument, and people have resisted it at this point. But suppose you grant this. Well, if it's something real, because only a real thing can be a cause, and it's something that has to exist, and science only talks about things that don't have to exist, but then the first cause is something supernatural, I just mean by supernatural what's beyond the domain of science. We should prefer simpler theories. The simplest theory is that there's only one first cause. The unity of the universe, the harmony of it, the fact that we've got the same laws of nature all through it as far as we can tell, suggests a single creator. Any creator of the universe is going to be very powerful. The universe is very beautiful at two levels. One is sort of the surface level, it just looks pretty. Large chunks of it look pretty. And also at the deep level, the laws of nature that scientists discover, or at least the physicists discover, are very elegant and beautiful. This suggests an intelligent creator who at least has strong aesthetic sensibilities, but also has life. And life isn't just beautiful, it's good. And so that suggests some goodness in the creator, some intelligence. Remember, this is already on the assumption that there is a first cause. So we're just looking, what can we tell from the universe? Well, it looks harmonious, beautiful, full of life. That gives us some reason to think the first cause has something to do with these things. So it points to, the universe then points to a very powerful, highly intelligent, supernatural creator, assuming there is a first cause. Assuming there is a cause, creator of some sort. I think the simplest theory is actually that this being is going to be infinite and perfect. And this isn't actually arbitrary. You kind of might think, if you've got something that has to exist, it doesn't make sense for it to have like arbitrary seeming parameters like a mass of 7.8 kilograms. Because then you can add, well, yeah, but why not 7.7? Why not 7.9? It just seems really arbitrary. Or partial knowledge. It's a being that knows all of physics but no biology. It seems like a necessary being that has to be the way it is, would have to be the way it is. And it seems like it wouldn't have arbitrary divisions, arbitrary levels. This level of power, it can produce 10 terajoules, but no more. It can, know these things but not others. All these seem really arbitrary, and there might be the case that these are the kind of limitations a contingent being, a being that doesn't have to exist, would have. But a being that had to exist seems like it would have to be much less arbitrary. And so one hypothesis that some philosophers very recently have made, my friend Josh Rasmussen at Azusa Pacific is one of the main ones, is that God is going to have all his parameters at 0 or infinity. So if he's very intelligent, his intelligence level isn't 0, so it's infinity. If he's very powerful, his power level isn't 0, so it's infinity. All of God's parameters are 0 or infinity, so if he's at least somewhat good, he's infinitely good, and so on. Because anything in between, you would want to have an explanation of why it's at that level. So the simplest theory, I think, in the end, is that there's a perfect and infinite being. And this, it seems, it's right to call that. Additionally, this theory can help explain other things like consciousness, morality, the meaning of life, or at least contribute to the explanations of these things. So it's not a theory just for why the universe exists. So I think there is something, there is reason to think that what Paul said in Romans is true, that by looking at creation, we can track back to the Creator. Thank you.
I have one question regarding to the principle of sufficient reason. So the theory says that something that does not have to happen, it has to be a reason or explanation. So it's still a little bit struggling about the argument against it. So like, could there be a mixture of randomness and certainty? Would that defeat this theory?
I think so. I think I think that was something that philosophers of science over the 20th century had to become comfortable with, and they eventually did become comfortable with the idea that you can actually give reasons that involve randomness. It's not there is a reason why when you tossed the die, it came up 6. Why? It was you tossed the die, and 6 was one of the options, and it had a probability of 1/6 of coming up. At an early point when philosophers of science were thinking about what it is to explain something, they thought you had to give some kind of a theory from which you could predict it with certainty. And that didn't fit quantum mechanics. It would imply that quantum mechanics really doesn't explain anything because you can't predict anything with certainty from quantum mechanics. So they weakened it a bit and said, okay, maybe all you need is to predict it with high probability. Well, as the history of the philosophy of science and reflection on it went, people started realizing, we actually, to explain something is to help you understand why it happened. Take a high probability thing. Let's say you've got a coin that is heavily weighted towards heads. So 80% of the time it comes up heads. You understand why it comes up heads. It's a random process, has 80% chance of coming up heads, has high probability. But they said, look, suppose it comes up tails. You understand what happened there too. It's not any more mysterious why it came up tails. It's less likely, it's less predictable, but it's not any more mysterious. You have just as much understanding on the basis of the cause, which is the toss, and the forces acting on the coin. You have just as good an understanding of why it came up tails as you did of why it came up heads, even though the tails part was less likely. And so they ended up concluding, by and large, that yes, you can actually have explanation even when the thing is unlikely. But it's not like everything has an explanation. Automatically has an explanation. It would be a substantive principle of sufficient reason. It's just when you can have causes that have a certain amount of randomness or indeterminism about them, where the same cause could produce more than one effect. And we have that, it seems like, all the time in quantum mechanics. And it seems like we have good quantum mechanics explanations despite this. So, yeah, I think you can have this mix. I think randomness is not something that is actually opposed to causation or explanation. At least if it's kind of a tame kind of randomness, where you can talk of the probabilities involved and say this is likely or unlikely. You might have this kind of untamed randomness that I think you would have if the principle of sufficient reason wasn't true, and that would be different.
So I want to go back to the notion of backwards causal chains,
Yeah.
the Kalam arguments. So it seems like without having to posit a new sort of metaphysical principle, I should be able to resolve all of those individual cases, so that the rod just seems to be a question of those sorts of physical objects can't exist, and ruling those out for a whole bunch of possible contradictions that come out as a result doesn't seem to be as weighty of a metaphysical price to pay than having to posit this new sort of principle. With the lottery paradox, that seems to be the problem of like a finite intellect trying to reason about the infinite, and so that seems to posit sort of epistemological problems. Again, the fact that we can't reason about it shouldn't then mean that we need to posit a metaphysical principle to clear it up. And then most pressingly, the Grim Reaper paradox. It feels like you're trying to argue from the impossibility of an infinity in the direction of division to an impossibility of an infinity in the direction of extension. So Aristotle already is going to tell us that we can't have an infinity in actuality in the direction of division, even though we can have it in potentiality, because we can always conceive of a further division or something of the sort. But the people we're arguing against in the Kalam arguments aren't worried about infinity in the direction of division in time, like you're hearing with your Grim Reapers. They're worried about it in the direction of extension into an infinite past time. And those feel like they're two different situations. And so when I do sufficient conceptual analysis on those sorts of cases, it again no longer seems necessary to posit a new sort of metaphysical principle.
Yeah.
Are those responses going in the right direction? You voiced uncertainty about the Kalam arguments yourself, so I'm wondering if you think that those are the right ways of potentially responding to those situations without needing to posit the principle that you were suggesting to posit.
Yeah. So, one can always try to just take all these paradoxes one by one and say, here's something that's wrong with this one, here's something, here's a reason why this one can't happen, here's a reason why this one can't happen, here's a reason why this one can't happen. There's a cost to piling on these things. You've got to say that about many paradoxes. The ones I gave are a sampling. Maybe they are the rhetorically most effective ones, but there are some others that seem also particularly pressing. Some of them might be handled by some of the things you said. Some of them I'm not sure. I'd have to think about them more carefully. But it seems it's always preferable to have a single story for a multitude of cases than a multitude of stories for them.
But I thought that was the sort of methodological principle you were suggesting, but it seems like it's preferable to have a whole bunch of stories that don't require us to posit new entities. This is from Occam's razor, rather than to have a single story, even if it is just one story, that requires us to put a new sort of metaphysical posit in the universe. We're positing a new principle, whereas the suggestion I was making was that taking them one by one, I can deal with them without needing to make a new posit.
I think you're going to end up with new metaphysical principles. So let's say you want to handle some of these paradoxes by saying, this is physically impossible. You need more than that. You need, not only is this physically impossible, but you couldn't have the kind of physics that the paradox involves. So we, of course, moved away from Newton's physics of perfectly rigid bodies some time ago, at least 100 years ago. But it would be a metaphysical principle that you couldn't have such a physics. And you would need, and so I think for some of these, you will end up with some sort of metaphysical principle. And maybe one's about how certain kinds of things can't be reasoned about by us. As for the compressed and stretched out infinities, right? So in the Grim Reaper, it's like, they bunch up the causes, and in the Kalam argument case, they're spread out and they go on to minus infinity. There's still a kind of one-to-one correspondence between the structure, the causal structure involved. So if you think this causal structure is fishy, then you should think it's fishy here. It's the same internal causal ordering. The only difference is here the lengths of time get shorter and shorter, and here they don't get shorter and shorter. It's not clear that that makes a significant difference.
Okay. My question is, so assuming, I want to just make an argument against the implication that if there exists a first cause, then there exists a God, or at least that transition there. Because, so from what I understood from you, it was the simplest explanation by Occam's razor would be a God. And I'd like to step back a little bit and say, okay, fine. The question is, what has to exist? And just using a little bit of intuition, if I exist, I can assume at least there must exist a universe. Just starting with that. And the implication that I see coming from you is that, or from this argument, I should say, is that if the universe exists, the universe, by being a material, scientifically observable thing, doesn't have to exist. But God does in some way, and he seems to be the simplest argument, and yet if God is infinitely powerful and infinitely wise and so on and so forth, then he is at least as complex, if not more complex, than the universe. And it seems like the simplest answer to start with is, yeah, the universe exists. Beyond that, I don't know.
And it's a necessary being?
And it's a necessary thing, just by my existence. That's as much as I can know.
Yeah.
However, it seems a little bit like conceptually God may sound simpler, but in reality it seems like God is way more complex than the universe. And so introducing God into the mix seems to me at least like violating the principle of Occam's razor.
mean by has to exist. I don't mean has to exist in the sense that we have to think it exists, or we can. I mean it has to exist in and of itself. So, for example, obviously I have to think that I exist, but I'm not a necessary being. I'm a contingent being. I don't have to exist. I may have to think I exist if I'm to be rational, and maybe I have to think the universe exists, but that's not what I mean by the necessity. I mean the sort of thing where it couldn't not exist in itself. Okay, this is just to clarify. Okay, so then we've got the Occam's razor point. If we think the universe is a necessary being, we end up saying we still have to multiply the kinds of things there are, because then there are two kinds of material things. There are material things that are contingent, that don't have to exist, like you and me, and then there's material things that have to exist, namely the universe. So we're still multiplying kinds of things. There's still some kind of division, but it's true. You're not adding this infinite thing. So what about the thought that the universe is going to be less complicated than God, less complex than God? I think there's two things about that. First of all, when we look at a theory, when we're Occam's razor, sometimes put. I mean, it's often it was historically put in terms of entities, but I think most of the time these people apply it to a theory, and the simplicity of a theory is in how simply you can formulate it. What can you say, and how simply can you say it? The theory that God exists, you could put like this. There is a being that has every perfection. And everything else follows, logically, about God. You get this zero infinity thing because you get zeros of the imperfections and infinity of the perfections. The universe, the theory is going to have a lot of parameters in it. It's going to say, here's the initial entropy level, it's this level. Here's the fine structure constant in the laws of physics. Here's this. Here are the laws of nature. They're not derivable from a simple, elegant theory like this. So we have a more complex theory at the base.
I would like to interject
Yeah.
in the sense that this is seemingly simple, but you'd have to define what perfection is for this to make sense. And I think that's where the problem might lie, in the sense that right now, just leaving it as it is, okay, sure, we can all disagree on what perfection might mean. And if you were to define perfection in that sense, my question is how would it's like behind one word which you have to define a lot of things under, you're hiding the complexity of what God might be. And so you may it's like me stating that, there's one equation which describes the universe, but inside that equation there are a lot of terms which have subterms and different elements to them.
Right. There are going to be always in these chains of definition fundamentals, right? Otherwise you have an infinite regress of definitions. So somewhere you have to have fundamental terms. And so what you want to do is, when comparing the complexity of theories, is get all the definitions back down to the further undefinable fundamentals. I am perfectly okay with taking perfection to be one of those. You are probably not. That might be a big difference on that.
I have a simpler question, so why should we prefer the simpler version?
Yeah, I don't. That's like one of the really hard questions of epistemology. It's sort of at the heart of, why should it's at the heart of our scientific enterprise to prefer the simpler one. But why is that right? I mean, yeah, we do in fact prefer it, generally speaking. Maybe not always, but generally speaking, we prefer the simpler hypothesis. Why? Why should we do that? That's a really hard question, and I think at that point I just kind of want to punt and say that's going to be hard for everybody to say why we should prefer that. You might take that to be partly constitutive of what it is to reason reasonably. That's just part of what it is to reason reasonably, is to prefer simpler hypotheses over more complex ones. My own theory is that to some extent I'm a follower of Thomas Aquinas. Thomas Aquinas had an ethics on which the right thing to do was grounded in our nature, in our human nature. And I think the right thing to think is also grounded in our human nature, and part of our human nature is to think, to prefer simpler theories, and that's actually why we should do it. But that is a highly controversial answer. But yeah, there are going to be multiple answers to this, and each of them is going to be really controversial. But I think if people generally do agree, we should do that. I mean, if we don't prefer the simpler theory, we really don't know any scientific stuff. So, you thought in Newton's time we knew that gravity was governed by this. Well, so we have this. Let's say we've got this gravitational equation. If we don't think we should prefer the simplest theory, here's another equation that fits the data just as well. That fits our observational data just as well. But of course, nobody thinks that one is true. Right, so if we can read that as 2 plus 10 to the minus 100. So 2.9901. That fits the data just as well because our data doesn't distinguish such tiny differences, but of course we go for the simpler theory, and we think the simpler one is, or at least more likely to be true. I think that's just part of our basic reasoning, is to prefer the simpler theory, and we should do that. Whether it leads to truth, how we know that it leads to truth, that's going to be a hard question to answer.
And regarding to simplicity and complexity, there is a Chinese proverb that goes, the study is infinite. Like, our personal study is infinite, but the study is, our personal study is finite, but the study itself is infinite. So I was wondering, how can we reconcile the two sides, that we have limited understanding, yet we can envision infinity? Like, why is it that in our finite minds and understanding can we envision something caught infinity? Like, why is that impossible? I mean, like, this is more just personal thoughts.
Yeah. So Descartes had thought this was something like this without the Chinese proverb. He thought this was an argument for the existence of God. He said, look, where do we get this concept of infinity from? We get our concepts, it seems like, from the world around us. There's nothing infinite around us. Where do we get this concept from? And he thought the only possible answer was, we got it from an infinite being. And so he thought this was a good argument for the existence of God. Almost nobody's taken him up on this as an argument. I've explored things in the vicinity, but I think it's a really interesting and difficult question where our concept of infinity comes from. And maybe something like Descartes, right? Maybe it's just, we have maybe there's some opposite answer. We just get the concept of the finite somehow or other from the finite things around us, and then we just negate it and say, no, not finite. That's infinite.